Look up at the night sky, and you're staring into eternity. Billions of stars, trillions of planets, more worlds than grains of sand on Earth. With that kind of scale, the question almost asks itself, are we alone? Logic says no. The math says no. The sheer number of galaxies, exoplanets, and life. Friendly conditions out there make it seem impossible that Earth is the only place where life emerged. And yet, the silence is deafening. For all our radio signals, telescopes, and ambitious searches, for all the SETI programs and sky scans and cosmic eavesdropping, we've found nothing. No signals, no spacecraft, no artifacts, no whispers, just static, just stars. This strange contradiction between the high probability of alien life and the total lack of evidence is what we call the Fermi Paradox, a question that has haunted science, philosophy, and human imagination for decades. If the universe is full of life, then where is everybody? It's a question that cuts deeper the more we learn, because the more we understand how common planets like Earth are, how ordinary our sun is, how early life appeared here, the harder it becomes to explain the silence. Maybe we're early, maybe we're late, maybe something happens to civilizations just as they begin to reach for the stars. Or maybe someone is watching. This isn't just about aliens, it's about us. Our place in the universe, our future, what we might become, and whether what we're searching for is out there, or a reflection of what we're afraid to find. The silence could mean many things, but it does not mean the question has no answer. So let's explore the possibilities. Let's walk into the void, not with fear, but with curiosity, and ask, once more, are we truly alone? Or are we just not listening the right way? We often imagine space as a vast ocean filled with possibilities. Alien civilizations, ancient signals, mysterious artifacts drifting through the stars. And yet, despite our efforts to listen, search, and scan the heavens, we've found nothing. But maybe the problem isn't that they're not out there. Maybe the problem is that space is just too big, too quiet, and we're looking on the wrong scale, in the wrong way, at the wrong time. To grasp how difficult it is to communicate across space, we have to first understand the sheer immensity of the universe. Light, the fastest thing we know, takes over 8 minutes just to travel from the sun to Earth. That's nothing in cosmic terms. Our closest stellar neighbor, Proxima Centauri, is over 4 light years away. That means if an alien civilization sent a message today from that star system, we wouldn't receive it until the year 2028. And that's if it was directed specifically at us, using a technology we're even capable of detecting. Now, consider this. Our galaxy, the Milky Way, is about 100,000 light years across. If a civilization on the far end of it sent out a signal the moment the Great Pyramids were being built, we still wouldn't have received it. Multiply that by the billions of galaxies scattered across the universe, and you begin to see the issue. Signals take time, a lot of time, and civilizations don't last forever. Even if intelligent life is common, it might still be rare in time. Civilizations could rise and fall in the blink of a cosmic eye, never overlapping long enough to communicate. We assume other life forms are alive now, listening now, broadcasting now, but that might not be the case. Maybe the galaxy has been full of voices, but we've arrived at the moment between transmissions, when one has ended and the next has yet to begin. And even if someone is out there listening, are we even speaking the same language? We've been transmitting radio signals for barely over a century. Our oldest broadcasts are just now reaching stars that are 100 light years away, a tiny bubble in a galaxy of hundreds of billions of stars. If someone is beyond that bubble, they don't even know we're here yet. And if they don't use radio, or if they communicate in ways we haven't discovered, quantum entanglement, gravitational waves, neutrino beams, then we might be surrounded by conversations we're not equipped to understand. Then there's the issue of direction. The sky is unimaginably large. We can't listen to all of it, all the time. SETI, the search for extraterrestrial intelligence, relies on pointed, narrow observations. We choose a target, a frequency, a time. But if someone out there is broadcasting from another direction, on another wavelength, during another era, we miss them completely. Imagine trying to tune in to a single radio station from across the world, at the exact moment it plays one specific note, using an antenna made from spare parts. That's what interstellar communication is like right now. It's not that no one's speaking, it's that the chances of catching a message are infinitesimally small. And yet, we continue to search. Because even knowing how unlikely it is, even knowing how vast and empty space can feel, we understand something crucial. Distance is not the same as absence. Just because we haven't heard anything doesn't mean there's nothing to hear. Maybe civilizations are out there, just too far, too faint, too different. Maybe we're all shouting into the dark, hoping someone's listening. Or maybe we're all listening, hoping someone else will speak first. So the scale problem isn't just a logistical challenge, it's a humbling reminder. A reminder that our perspective is limited, our reach is small, and the universe doesn't owe us answers on our timeline. It's vast, ancient, and patient, and if there's anyone else out there, we might need to be just as patient to find them. If the universe is so vast, so ancient, and seemingly so fertile for life, then why does it still feel so empty? One chilling possibility is that life may not be the problem, it's longevity. In other words, maybe intelligent civilizations do arise, but they just don't last long enough to say hello. This idea is known as the Great Filter, a concept that suggests somewhere along the path from dead matter to advanced spacefaring civilization, there exists a step so difficult, so improbable, or so self-destructive that almost no species makes it past. Something stops them. Something filters them out. Maybe the filter is behind us. Maybe the emergence of complex life is rare. Maybe the leap from bacteria to multicellular organisms, or from tool use to language, is so unlikely that it's only happened once. Here, on Earth, if that's the case, then we're rare. Not alone, necessarily, but a miracle of probability, a cosmic lottery winner. But there's a darker version of this theory, one where the filter isn't behind us, but ahead. In that version, the universe is silent, not because life hasn't begun elsewhere, but because civilizations that reach our level of development tend to destroy themselves. And if that's true, then we may be next in line. It's an unsettling thought, but it isn't science fiction. Look around. We're a species with the power to alter the climate of an entire planet, to create artificial intelligence we don't fully understand, to build weapons that could erase entire cities in seconds. And we've only just begun to scratch the surface of space travel. We're still fragile, still young, still learning how to wield the tools we've created. Maybe that's the pattern. A species reaches a certain point in technological advancement, but it outpaces its wisdom. Its progress becomes a weapon. Its intelligence becomes unsustainable. And long before it learns to spread across the stars, it collapses through war, ecological ruin, machine rebellion, or something we can't even imagine yet. It doesn't have to be dramatic. It could be slow. 1,000 small decisions that gradually make the world uninhabitable. A failure to cooperate. A reliance on unstable systems. Collapse doesn't always come with explosions. Sometimes it comes with apathy, with blindness, with delay. But the Great Filter isn't just about destruction. It's about bottlenecks. Maybe survival depends on making the right choices at exactly the right time. And maybe only a few species ever get that moment right. Maybe we're standing at the threshold of our own filter now, and we don't even realize it. Or maybe the filter is biological. Maybe intelligent life is rare, because it tends to be self-limiting. It turns inward. It becomes dependent on comforts, distracted by its own creations. It loses the drive to explore. In this view, civilizations don't die out violently, they just fade. They retreat into virtual realities, into isolation, into stillness. And of course, it's possible that the filter is something external. Maybe the universe itself contains hazards we haven't encountered yet. Cosmic events, rogue artificial intelligences, or even predatory civilizations that eliminate threats before they can rise. These ideas veer into the speculative, but they remind us that we're still infants in a universe we barely understand. So where does that leave us? If the great filter is behind us, then maybe we're a rare success story, a precious exception to the rule, standing at the dawn of something greater. But if the filter is still ahead, then we may be one decision, one invention, one moment away from silence. This possibility doesn't have to be paralyzing. It can be clarifying. Because if we know that most civilizations fail to pass this test, then passing it becomes the greatest challenge we will ever face. Not reaching Mars, not building faster ships or stronger AI, but surviving ourselves, learning to balance power with restraint, progress with wisdom, growth with humility. The Fermi Paradox isn't just about aliens, it's about fragility. It's about whether intelligence is a flame that always burns out, or one that can be carefully carried forward into the deep, quiet dark of space. If there is a great filter, we may already be moving through it. The question is, will we make it to the other side? Let's suppose for a moment that we're not alone, that intelligent life is out there, scattered across the galaxy, perhaps even closer than we realize. Civilizations that are older, more advanced, more capable than us. And yet, they remain silent. No contact, no signals, no ships appearing in our sky. Why? One answer lies in a strange and unsettling theory known as the zoo hypothesis. It suggests that we haven't been contacted, not because we're alone, but because we're being deliberately avoided, watched, studied, left alone on purpose, the way we might observe animals in a nature reserve without disturbing them. To these hypothetical observers, we may seem primitive, young, unstable, perhaps even dangerous. A civilization barely out of its adolescence, still learning how to manage its own planet, still struggling with war, inequality, and sustainability. And like biologists hiding behind tinted glass, they choose to watch from a distance, waiting to see what will become. This idea doesn't require anything magical or malicious. It just assumes that other civilizations have their own version of ethics, of non-interference. That just as we set rules for observing wildlife or uncontacted tribes, advanced species might set rules for interacting with younger civilizations. It could be part of a broader galactic code. Don't interfere until they reach a certain level of maturity. Perhaps until we achieve interstellar travel, or make contact ourselves, or pass some test of technological and moral responsibility. Until then, they watch, silently, invisibly. And that raises a fascinating possibility. What if we're already being observed, but we simply don't know it? We often imagine alien contact as something obvious, a ship in the sky, a message on our radios, a mathematical code beamed through the stars. But what if advanced civilizations operate on levels we can't perceive? What if their technology is indistinguishable from nature itself, woven into the structure of space, hidden in quantum shadows, or cloaked in ways we'll never detect? They wouldn't need to land or announce themselves. They could study our broadcasts, our internet, our satellites. They could observe our biology, our cities, our social systems. all without leaving a trace. We might be surrounded by signs, and simply unable to recognize them. And even if they did reveal themselves, would we be able to understand them? Think of how hard it is for two humans to fully understand each other. Now imagine trying to interpret the motives of a civilization millions of years ahead of us. Their logic, their language, even their perception of time might be so different that we'd mistake communication for background noise, or ignore it completely. There's also a darker version of the zoo hypothesis, not one of careful observers, but of caretakers or jailers, that Earth is not just a reserve, but a kind of containment. That contact isn't withheld because we're not ready, but because we're being intentionally isolated. It sounds like science fiction, but even in that fiction, there's a question worth asking. What if the silence is intentional? What if the universe is full of life, but it chooses to leave us in the dark? It's hard to prove or disprove this idea, and that's part of what makes it so eerie. If someone didn't want to be found, would we even know they were there? Maybe we're a cosmic experiment. Maybe we're being allowed to evolve naturally. Maybe we're on a kind of universal probation, one chance to prove we're worth contacting, worth including in something much larger than ourselves. Or maybe the silence is the test. The zoo hypothesis shifts the focus from them to us. Because if we are being watched, if someone is out there evaluating who we are, then every war, every invention, every act of compassion or cruelty, they're not just part of human history. They're part of a much bigger conversation, one we might not even know we're having. And when we finally do speak into the stars, when we finally step beyond our own atmosphere in a meaningful way, maybe the response won't come as a surprise. Maybe it will sound like a voice we've been missing all along. In a forest, quiet doesn't always mean emptiness. Sometimes it means danger. Sometimes it means everyone is hiding, watching, waiting. This is the unsettling core of the dark forest theory, a response to the Fermi Paradox that offers a terrifyingly simple answer. The universe is quiet because it's safer that way, and anyone who makes noise risks being eliminated. The idea comes from science fiction author Lou Sixon in his three-body problem trilogy, but it's taken seriously enough in theoretical discussions that it deserves attention. It reframes the universe not as a peaceful void waiting to be filled with communication, but as a dark forest full of hidden hunters, where every civilization is both a potential target and a potential threat. Let's break it down. Imagine you're in a forest, pitch black, and filled with others like you, each one intelligent, each one alone. You don't know who's out there. You don't know their intentions. You don't know how powerful they are. All you know is this: in a place where trust is impossible, silence is survival. Now apply that to the galaxy. Each civilization, upon reaching a certain level of advancement, must face a decision to broadcast its presence into the stars or to remain hidden. The problem is, revealing yourself means taking a cosmic risk, a bet that whoever hears your signal will be friendly. But what if they're not? The stakes couldn't be higher. Even the tiniest risk of a hostile response could mean extinction. So the safest strategy: stay silent, stay hidden, listen, but don't speak. And if you do detect another civilization, eliminate it before it eliminates you. It's a grim logic, not because it assumes malevolence, but because it assumes uncertainty. No matter how advanced a species is, they can't know the true intentions of another. And in a universe where destruction could arrive at the speed of light, some might choose to shoot first and never ask questions. This could explain a lot. Maybe civilizations do exist, but the first ones to appear realized the danger of exposure. Maybe they set traps. Maybe they wipe out anything that dares to announce itself. Or maybe they've simply decided that the cost of contact outweighs the benefit. It's also possible that we're the naive ones. That by sending out radio signals, blasting music into space, and attaching maps to probes, we've been making noise in a forest where everyone else has already learned to whisper or vanish. Of course, we don't know this theory is true, but it's worth noting that it requires no special technology, no conspiracies, no magical alien cloaking devices. Just caution, fear, and a basic drive to survive. Because if intelligence is rare in the universe, and survival is the ultimate goal, then staying hidden isn't cowardice, it's wisdom. Still, the dark forest theory presents a chilling picture of our future. If this is how the universe works, then contact won't come with a message, it will come with silence. Maybe we've already made too much noise. Maybe we've drawn attention. Or maybe no one's heard us yet. There's a deeper message here, though, a kind of mirror, reflecting back our own fears. We imagine the universe is dangerous, not because we've seen violence among the stars, but because we know how dangerous we can be. We project our own instincts, our own histories, our own strategies onto the cosmos. And what we see is darkness. But that darkness doesn't have to be absolute. Maybe the forest is full of civilizations that learned to hide until they could trust, until they could be sure they wouldn't be destroyed for speaking. Maybe, when enough of us are ready, the silence will finally break. And maybe that's what we're waiting for. Not a sign from the stars, but a moment where we, too, learn the value of caution, the danger of noise, and the responsibility of making ourselves known. Because in the dark forest, every voice is a risk. But one day, someone will speak. The question is, will it be a greeting or a warning? We began with a question that has echoed through every observatory, every radio dish, every curious mind that's ever looked up at the night sky. Are we alone? And after exploring vast distances, existential filters, invisible watchers, and silent predators, we find ourselves no closer to an answer. But maybe that's the point. The silence of the universe isn't just a scientific puzzle. It's an emotional one. It's the tension between what logic tells us, that life should be everywhere, and what experience keeps confirming that we've never seen it. Maybe the answer lies in the sheer scale of space. Maybe civilizations rise and fall too quickly to ever overlap. Maybe most never survive long enough to reach beyond their own stars. Or maybe some do, but choose to watch us from the shadows, preserving our innocence or protecting themselves. And then there's the darkest possibility, that silence isn't the absence of life, but the result of what happens when life speaks too loudly. That the universe is full, but quiet, because everyone has learned the hard way that survival means silence. But whatever the reason, one thing is clear. The silence has meaning. It reflects our curiosity, our fear, our hope. It challenges how we see ourselves, not just as individuals or as a species, but as a possible type of intelligence in a universe that may or may not be listening. We may never know the answer, not in our lifetime, not even in the lifespan of our civilization. But the very act of asking, of listening, of sending signals into the dark, of wondering, changes us. It makes us part of something bigger. Because whether or not there's anyone out there, we are here, thinking, questioning, dreaming beyond our atmosphere. And maybe, just maybe, that's what makes us ready. If this exploration made you pause, sparked your imagination, or left you wondering just a little more deeply about our place in the stars, please like, comment, and subscribe to the Story Teller Panda. We'll keep asking the big questions, and we'll keep searching the skies together.